Hello everyone, welcome back to my math channel online today. Today is such a beautiful day in BC, British Columbia, Canada. I looked through my window, I could see like on the pine trees, green and fresh. To me, it's like breathtaking. I love nature and I love animals. Anyway, today I will talk about the exponential function. And yesterday I have shown you from my MS PowerPoint presentation about the characteristic of the exponential function. So today we progress through the lesson about solving exponential function. So let's take a look at on the board. I have the two examples of how the exponential equation look like. So the first example, y equal 2 over 3 x to the power 4. And you notice in the first example, the power is a number. The base here is the base of x. And the second example, I have y equal 4 to power 2x plus 1. So if you notice, in the second example, the power turned out to be the unknown variable, 2x plus 1 on the top as the power. So this kind of equation you will see in the exponential function. So let me show you how we'll do number one first. So number one, it says solve for x. So I have x to the power 3 over 2 equal 27. So this example, this number one look like the first example here. The base is the x and the power is a number. Now, how we're going to solve this equation? And if you look through on the question I wrote on the board, none of them look similar. So I try to give you varieties of the form of the equation look like. So let's solve the number one first. So first, you know that we want to solve for an x variable. So to have an x, now this x, if we solve for it, actually it is x to the power 1. But here we have x to the power 3 over 2. So to solve for x, we want to solve for x to the power 1 because x to the power 1 is just x. So how do we get rid of the power in here? And noticing that in the equation, we have left side equal right side. So the rule is whatever we do to the left, we have to do the same to the right so that our scale still balance, right? It's like you put a heavy weight on here, then you have to put a heavy weight on here. Or you take away the heavy weight from here, then you have to take away the heavy weight from here. So your scale, which is the balance equation, still balance. So that's the idea. So in order to get rid of the power here, to get x to the power 1, I will multiply this with the reciprocal fraction 2 over 3. And when I do like this, it wouldn't be fair if I only do to the x and I did not do to the number here. So to compensate for that, it means 27 to the power 1 here also have to time with 2 over 3. So by doing that, the scale still balance. At this point, I can cancel the 3 on top here with the 3 at the bottom here, and 2 on top here with the 2 at the bottom here. So I will left with x to the power 1 because everything cancel, then it becomes power 1. So now by doing that, I get rid of that. But how about the right hand side? Now the right hand side is just 27 to the power 2 over 3 because one time with anything is just the same. So I'm just erase this and let's move it closer a little bit. So now in fraction, if you learn the law of exponent already in Math 10, you know that the rational fraction, you can twist it, become a radical. So the bottom here stands for the root. And the top here is the power. So I'm going to turn this into the third root because that's how it looks like, the third root here. And I put number 27 in here and I'm going to power it by 2 outside. Or I can power inside, doesn't matter, I put inside or outside, it doesn't change. So x will become third root of 27, it equals 3 because 3 times 3 times 3 equals 27. So third root of 27 is 3, but you power 2, so equal 9. And that is the answer for the x. Okay, so now I think that a couple of the solving equation here is not too difficult. I believe you can follow me, no problem. Now, this time we have a 2x to power 3 over 4. Basically, we can separate them like the bracket like that. So first of all, I want to get rid of number 2 here. It means that I will divide both sides by 2. So when I do this, I'm not changing anything because whatever I do to the left, the same I do to the right. So by doing this, I will cancel the 2 and bring the x down. And my x is 3 to the power 3 over 4 will be equal 27 again. At this point, I am going to time this with 4 over 3, reciprocal again, and this number will time with 4 over 3 as well. And 1 time with 4 over 3 is just 4 over 3. So here I can cancel it, cancel, and again I left with x to power 1, and here I can turn it into the third root again for 27, but this time will be power 4. So this will become third root of 27 equal 3. 3 to power 4 is 81. So that's the answer. 3 times 3 times 3 is to the power 4 is 81. So we're done with the first question and the second question. So now I'm going to go to the next question. So the next question, you see that this is different, right? Because we have a bracket, we have a whole expression instead of just one number like this, right? But the way we deal with it is very similar. So to get rid of the fraction power on top, I have to time with 3 over 2. And on the right hand side, I have to also time with 3 over 2. Power 1 times with 3 over 2. So by doing this, I can cancel the 2 with the 2, the 3 with the 3, and I left with power 1. So this bracket will become 2x plus 1 equal square root of 4. You see this root is the bottom square root and power 3. This is the power, the top stand for power and the bottom stand for the root. So here I will have 2x plus 1 equal square root of 4 is 2. 2 to power 3 equal 2 times 2 times 2, which is 8. So at this point, I will pair this with this. It means that to solve this equation, I separate the variable x on one side and number on the other side. So I'm going to bring the 2x down here, but I'm going to move the 1 over to the right. Now on the right hand side, I have the number 8 still there, and I'm going to move the 1 over. So positive become negative when I move over. So I have 2x equal a minus 1 is 7. Now divide both sides by 2. I got x equal 3.5. 7 divided by 2 equal 3.5. So that's the answer. Now for the question 4, you can see that we have left side here and right side here. And the base here is not the same, 27 and this is 9. But if I notice that, I know that I can turn them into the same base. So it's easy to pair them, right? So first step, I will turn this number and this number into the same base, which is I can make this become 3 to the power 3. 3 to the power 3 is 27, 3 times 3 times 3. And outside, of course, I still have this expression power on top, right? It nothing change. Now this I also can turn into the power 3, which is 3 to the power 2, which is 9. And outside, I still have this power on top. At this point, I can distribute the power 3 here to this expression. So I will have 3 to the power 3 times 2 is 6x. 3 times 1 is minus 3 equal. I'm going to distribute this to here and distribute this to here. So I have 3 to the power 2x. 2 times 2 is plus 4. So that's the idea. I don't have room, so I'm going to have to copy this question over before I erase it. So I'm going to have to erase this bar. So I'm going to copy this one here so that we can work on it later. And C 3, 4, 3, and x minus 1 equal 49, 2x minus 1. Okay, so now, sorry about that. I am going to continue with what step we leave here. So let me erase this. Okay, so now they have the same base, 3 to the power 6x minus 3. You see 3 to the power 2x plus 4. Now, the only way for this equation is left side equal right side because the base already equal. It means that the top here have to be equal to make these two numbers equal. Therefore, now we can ignore the base and just say 6x minus 3 equal 2x plus 4 because our purpose is to solve for x, right? So now, just like normal, back into normal equation, I'm going to keep the x on the left and move the number to the right. So I'm going to keep 6x down here. The 2x, I'm going to move back to this way to put them together side by side, right? And make sure I change the sign when I move. This is positive become negative when I move it. So minus 2x equal. I'm going to keep the number 4 on the right. I'm not changing it. The number 3, I move it. So I have to change the sign. Negative become positive. So now, continue with this. I have 6x minus 2x equal 4x equal 4 plus 3 is 7. Divide both sides by 4. I have x equals 7 divided by 4. And 7 divided by 4 equal 1, 4, and 3 on top. Okay. So I'm done with that question 4 as well. Now I'm going to go to this question, and this is the last question I want to show you. Let me see if I have any more interesting questions I want to show you as well. Okay, so now for this question, we have a fraction on the left and we have a whole number on the right with the power on top. So what should we do in this case? Let me see. Now, 1 in this position, we can twist this, we can bring this up top, right? But we have to do something with the power. So I'm going to let 3, 4, 3 go bringing up top. So 3, 4, 3, and of course down here, 1, right? However, the power will go with him as well, but I have to put a negative outside the power, because when you twist the position from denominator become numerator, you have to also change the sign of the power down here. Positive become negative. That's the rule in the law of exponent. So it means this is over 1, and over 1, I don't need to write it. So it's just like that. I'm going to copy this exactly the way it is. Now I notice that I can turn this to the same base, because this can turn into the power 7, the number 7 to power 2. And of course, 7 to power 2 equals 49, 7 times 7, right? And out here, I still have that, the power on the top. So now I'm going to have to change this number into the same base like that. So I think this is 7 to power 3. Is that right? 49 times 7. No, maybe to power 4. Okay, let me check. Seven to power 3. Yes, 7 to power 3 is 343. So this is 7 to power 3. And I'm going to distribute the negative in the bracket here. So I have minus x, minus with minus become plus 1. So now I'm going to time this number to the bracket here. So I will have 7 minus 3x and minus 3. Sorry, plus 3. See the plus sign, so 3 times 1 is 3. Equal, I will distribute to the bracket outside here as well. So I will have 7 to the power 2 with 4x, and 2 times minus 1 is minus 2. So now, because they are the same base here, 7 and 7, I can use the same trick. I'm going to pair the power here with this power. So I will have minus 3x plus 3 equal 4x minus 2. Now I'm going to solve for the x. And how do I'm going to solve for the x? I'm going to move the 3x over to the right-hand side. And when I move, minus become positive. So now on the left, I still have 3. I copy it down. So I'm going to move this over here. So that will become plus 3x and plus 4x still there. I'm going to copy it down. Minus 2, I'm going to move it over. Minus 2, move it over, become positive 2. So now I continue. I have 5 on the left. 3 add 2 is 5. And on the right hand side, I have 7x. 3x plus 4x, 7x. So now I'm going to divide both sides by 7. So x equal 5 over 7 is my answer. So I'm done on the solving exponent here. I think that is very much for the 5 example I would like to show you today. And I think if I find some pattern is more challenging, I will give you another video look like this for the next lesson. But that is very much on the variety question I show you now. Okay, so I hope you enjoyed this video and everyone have a nice day. Thank you for watching. Bye for now.